Okay, now this is about Chapter 2 and some overview and other supplemental information that I think is important. First one, I have major components of computer hardware. Because so many electronic devices that we are using. Could be your desktop, laptop, tablet, cell phone, and components we have are very similar. CPU, hard drive, RAM, hard drive or RAM, graphic card, of course it has a screen. So those are some components that most of those devices will kind of share the same hardware. And first of all, I have a CPU, Central Processing Unit. It has two important jobs to do. One is calculation, the other is moving data from one place to another. For example, moving data from hard drive to the processing unit, or a particular application to the printer. So I just moving data one place to another. The other important information about CPU is core of the processes. Core is like a capacity of your processing data. So if you have a dual core, you can say there's two different jobs you can do. If you have a quad core, meaning that you have four different processes you can do at the same time. Of course, it's theoretically. And in terms of measuring the power or speed of CPU, we use hertz, clock speed, in other words. So that will indicate number of cycles the data can be processed per second. So if you have a megahertz, meaning that it execute about 1,000,000 cycles per second. If you have a gigahertz, that's billion cycles per second. So that's how fast the CPU can execute the data. The second component we have is hard drive. Either you have a traditional hard drive or SSD, solid state drive. We are seeing this SSD more often, so if you get new computers lately or last few years, chances are you should have SSD, or you have options to choose hard drive versus SSD, of course. And SSD costs higher, but much safer, faster, powerful. The booting time is so fast, for example. And third kinds of component we have is RAM, random access memory, so that we can access this space pretty quickly. Rather than access to the hard drive, it takes more time. So that's why we have a RAM available, so we can do the processing much quicker and save resources. So RAM is more like using a notepad. If you have a large notepad, you can write it down more information on the notepad. If you have a smaller one, you have limited space, you can write it down. So you want to have a larger notepad. It's a larger size of RAM, so that you can run multiple applications at the same time. Then we have a graphics card. Sometimes we call it video card, same thing. And graphic card basically dictate how to use pixels on the screen. So if you have a larger capacitive graphic card, and you can show much higher quality of picture with very fast time. So that's why people want to get a pretty powerful graphics card these days. And graphic card costs very high lately, and probably much higher than CPU. And we have two different kinds of cards. It's not kinds of, depending on how your cards are embedded. If you have a dedicated graphics capabilities, meaning that graphics, the capability or the components of graphic card functions is loaded on your CPU. So CPU or motherboard is already installed, so you don't have to install graphics card. Of course, the functions are limited because this is already installed. However, if you have I think I am telling different, not reversely. I should say integrated. Integrated is already installed or embedded. Dedicated that's something you have to install yourself so that you can have a larger capacity or very powerful graphics card. So you can choose any types of graphic card you want to use. Well, the other information we need to understand is binary number system. I think we have again upload to the Go view so you can take a look what we have with a full capacity of this binary number system. And I'm going to give you some summary of binary number system. The reason we need to understand this, anytime you use computer, the data will be converted into binary coding. And same thing, our computer take a binary number system and convert it into the numbers or letters that we can understand. So that's why understanding binary number system is important. And more specifically, converting binary number to base numbers, or the other way around, base number system to binary number system. Base number system is number system that we are using every day, right? 0, 1, 2, all the way to the 9. So that's 10. Binary number, 0 and 1, only 2, right? So that's why we call binary number. So anytime you want to convert binary number to base 10 number, for example, we have 1, 1, 1, 1, 1, 1, 1, which is 8 ones. Okay, that's the typically that's how you represent binary number, 8 bits. Okay, series of 8 bits. And when you convert to the base 10 number, and all you have to is take 1 and multiply by 2 to the 0. Okay, the exponent is 0 and the base is 2. Why? Because this goes up by 2. So every digit goes up by 2. Okay, so from the rightmost position, and take the value and multiply by 2 to the 0. Then next, from the right, the value is 1, right? But their exponent is 1, 2 to the 1. So multiply. Then you just add it. So you keep adding all the way 1, 2, 3, 4, all the way to 8 bits. And you will have a 255. If you add them up, you have a 255. So that's how you're going to convert. Same thing, another example, using 0, 1, 0, 1, 0, 1, 0, 1. Same thing, from the rightmost position, take 1, multiply by 2 to the 0. Next position, 0, then you take 2 to the 1. Then you keep adding it all the way to the 0. That's 0 times 2 to the 7. And you get 85. Well, same thing, if you convert 85, you should be able to get 0, 1, 0, 1, 0, 1, 0, 1. Okay, that's what we're going to do next. Just like that. Well, we're going to use different number at this time, base 10 number, which is, the the number we are using every day, 90, but we want to convert to the binary number, 0 or 1, okay? So again, using 90, this time it's a little different from binary number to base 10, and you line up 2 to the 7 to the 2 to the 0, then you take whatever number you're trying to convert and look at the largest number that without going over 90. Okay, so 2 to the 7, which is the largest number, that's bigger than 90, so it doesn't go into 90. But 64, which is 2 to the 6, can go into 90. So you take 90 minus 64, then it'll give you 26. That's the remainder, right? So what we got, 2 to the 7th, we didn't use, which is 128. So you got 0. You assign 0. 2 to the 6, we just use it in this calculation. So we'll give 1. So anytime the digit position has been used, then you give a 1. The digit doesn't use, you'll give a 0. Okay. Next, the remainder is 26, right? So 2 to the 5th, right? 2 to the 5. 2 to the 5 is 32. 32 is bigger than 26, so you cannot use. So 2 to the 5th goes to the 0. You give a 0, right? Now 2 to the 4, which is 16. Now we can use 16 because it's smaller than 26. So you calculate that, subtract it. Subtract, you got 10, that's the remainder. And in terms of giving 1 or 0, that's how you're going to do it. Why? Because 2 to the 5th position we didn't use, so it's got 0. 2 to the 4th, 1, because that's how we subtract it. Okay. Next, 2 to the 3rd with 10, right? 2 to the 3 is 8, right? So we can use it. 10 minus 8, remainder 2. So we can give it 1 to 2 to the 3 position, and 2 to the 2 we cannot use. Why? Because the remainder is 2. 4 doesn't go into 2, so we can skip 2 to the 2 position and give it 0, just like that. And use 2 to the 1 in our calculation, which is the next calculation, 2 minus 2, and remainder is 0. Okay, so if we do this step until you get 0. So 2 to the 1 position got 1, 2 to the 0 will get 0. Why? Because 2 to the 0 position, which is 1, was not used in this calculation. Okay, so final answer will be from left to right, 0, 1, 0, 1, 1, 0, 1, 0. Okay, that's left to right. 0, 1, 0, 1, 1, 0, 1, 0. Right, so try 150 yourself. And if you have any questions, let me know.